Hi, I'm Neil Millard, the DevOps expert, Professional of the Year 2024. Today, I'm going to be talking to you about DevOps and some questions, or rather the answers to the questions you might have. Welcome to DevOps Practices and Principles. What you need to know about DevOps. So what are the core principles of DevOps? One of the core principles is automation. Automate things, or to put it another way, have one button click to do stuff. Or even better, have no button click at all and do stuff. A button click is just a trigger. It can be triggered by a person, a DevOps engineer, even a customer. Other triggers exist, like timings. Do this thing at 4 o'clock in the morning for me. So if you're using GitHub or other source code tools, you can tell it to interact with a webhook or something based on an event. Somebody commits to some code into the repo, and then it can use that as a trigger to do something, this magical thing that we're automating. Build code, run tests, deploy code, all that sort of stuff. Collaboration is also another core principle. Collaboration is working with other people who know what they want. So other experts in their field. So DevOps is quite a blanket role. And there's lots of other specialist roles that can be within DevOps. So DevOps can include a platform engineer that knows how to build a whole platform of tools. Or to break that down a little bit more, cloud infrastructure. And DevOps also requires developers and testers, and usually somebody to gather the feedback from the customers, business analysts, and then as a team that we'll get onto later, somebody to organize the team, or at least help lubricate the organization of that team. Cooperation doesn't end there. It also means you can reach outside into other teams. So if you need a specific skill set for whatever the customer's after, maybe you can reach out to the database administrators, or over to the data analysis team, or over to the artificial intelligence team, whatever that is. Another core principle is continuous improvement. It's all very well having a system and processes and automating those processes, but sometimes those processes aren't as good as they could be. They might have unnecessary steps, or they might have steps in there that are missing entirely. You might need some extra approval, or add extra tests in. But the process isn't just about what you've automated, it's also about the human side of the process as well. So we can continue to improve not only what we're doing as people, but also what the tools are doing as their tooling, and even introduce new tools, or maybe sometimes chop some tools out. Continuous improvement is making everything better, faster, slicker for everyone involved. And that can be adding things, and it can be removing things, and sometimes it can just be tweaking things. Another core principle of DevOps is customer-centric action. Or to put it another way, self-service. I want to make sure that whatever I do helps the customer do what they want to do. And if they don't have to talk to me about that, then that's even better. Because talking to me means they have to explain where they are. I then have to understand where they are and then provide something for them. If those 3 steps can be turned into a button, then the customer can get on with what they want to do faster. They don't have to take the time in order to explain it to me and for me to understand. So self-service speeds everything up, because not only can they just click a button and get on with it, they haven't even got to wait until a DevOps person is around to listen to them first. We're not holding them up, they're just doing what they need to do. So providing them with a quality service, so the button does what they want it to do. It's reliable. When they click that button, it does the thing it's supposed to do without breaking. And support in case the button disappears. I don't know. But we want to make sure that it's fast and satisfies the customer need and provides them with an awesome experience. And finally, another core principle of DevOps is infrastructure as code. Well, anything as code, really. Documentation as code, infrastructure as code, cloud automation as code, APIs as code. If we can encode everything into code, that means we can automate it. If it's automated, that means we can put a trigger or a button in front of it. And all of those things means that when we click something, something happens. And if it's in code, it's predictable. We know what it's going to do because that's what the code says. And we also know that it's going to do exactly the same thing every time we trigger that process because that's what the code does. Of course, I say exactly the same thing. If we're going back to continuous improvement, then we can make things better. But the end result should be the same regardless of how it's performed. It's a bit like when somebody comes to clean your house. You don't really mind which order they clean the rooms in as long as the whole house is clean. So infrastructure as code helps us build infrastructure the same way every time so that we get a consistent result. I know one of my customers has the same piece of code to build the same server. They use this code to build all of their servers so that all the servers are the same. This keeps things consistent, easy to support, and of course, if they're all the same, then everyone knows where they are. But how does DevOps improve software development? So it reduces the cycle time. So the cycle time is the time between something breaking and something being fixed. Often this is tied very closely to the time it takes them to create an idea, program the idea, test the code, and then deploy the code. And if we can reduce all of that time due to automation and fast feedback and a couple of other things I'm going to mention in a minute, that we can reduce that cycle time from when a item, a feature, a bug is discovered to when it's fixed in production. Because we use automation, it does the same thing every time. Because we use cross-team collaboration, we can have business design, coding, and testing. We can automate all of those. When they're all automated, we're all singing from the same basic sim heat. Therefore, higher quality code results. We know the code is higher quality because we've had collaboration from other viewpoints and other people on the team. We know it's higher quality because it's been tested. And we know it's higher quality because of all the product enhancements that have been requested by the customers. So higher quality provides a better service to everybody. Increased reliability of the code as well. Again, we come back to the automated tests. The biggest advantage of automated tests is it will test your code. But you can also test your tests. How good are your tests? Do they catch all of the code that you've written? Do they catch all of the offshoots and edge cases that can happen? And more importantly, can it test against regressions? So part of reliability is when you're fixing one bug, you don't want to fix that one bug. You want to fix that bug and not break anything else. And by having the tests in there, you're assuring yourself that you're not breaking anything else. Everything else should work as it did before. And this is where the reliability and the automated testing really comes into its own. The time taken to write those tests does seem like a bit of a dead time until you deploy something to production and realize that a bug has crept in that you fixed ages ago, or that one small typo in an unrelated file has now brought the entire website to a standstill. A regression test would have fixed that, or would have spotted it in order for the developer or the rest of the team to fix it before it got to production. DevOps also promotes a better feedback loop. What do I mean by that? is if you've got a quicker time for writing the code, testing the code, and deploying the code, and then ultimately seeing how it operates, the quicker you can shorten that cycle, as I mentioned earlier, then we're still in the same mindset from when we wrote the code. So if something's not quite right and it needs tweaking, we can then tweak it and then just go through the deployment process again. If that deployment process takes an entire weekend, then we're unlikely to remember what we knew at the beginning of the process. Whereas if that entire process only takes 20 minutes, then we're pretty much in the same state that we were when we wrote the tests. And so that something is go wonky and the code isn't quite right, we can revisit it and redeploy it. Another 20 minutes passes and we're already improved things. That continuous improvement not only to our own processes but also to the code that we're writing. And so we can achieve that by having that feedback loop. Customer asked for this feature, we programmed that feature, we deployed the feature, and within the same day sometimes we can then say, customer, would you like to go see if that suits your need? And they can say, wow, yes, it does. Or then they can say, no, the colors are wrong, or whatever their feedback happens to be. And due to the short time it takes in order to get that stuff into production means that the feedback is a lot quicker, a lot slicker, and everyone's always on the same page without context switching. And the final point I'm going to touch on this subject is enhanced security. In the same way that we can test the code for regressions, we can also ensure that there's tests in there for security. A lot of software, some of it is like the core software that you've written, and in order to speed up development, libraries and other software is used that's written elsewhere. And because that software is elsewhere, that could have bugs in. Sure, that happens. But it could also have security issues in there. So as well as an external security issue, we can also test that our own security issues are tied. So the security is a number one priority for, say, a security team, and we can bring that in the form of tests. The test can make sure that various attacks on the website don't have any effect. That when we're asking for input from a user, they can't just type in something and our code goes haywire. When the code is delivered and on a server, we can do automated penetration tests in order to make sure that the physical, or at least the network access to the server, is secure, and we don't want any data leaks and things like that. And so by having these processes, we can enhance the process by having the security tests in there. And if the tests are automated, it also reduces, or at least doesn't impinge greatly on that feedback cycle. So that's the benefits. How can we measure that we're doing a good job? What are the key metrics of measuring DevOps success? The deployment frequency, for me, is the number one metric that I look at. If somebody is doing their code and they've got a load of changes all at once and they're bundling it in and they do a deployment, say, once a month, then I know that doing all of those changes all at once inherently makes it more risky. You're not just deploying one small change, you are deploying a whole batch of changes, and any one of those could cause instability. Worse still, any one of those could interact with another one of those in an unexpected way. Or the absolute worst case is that big bundle of changes you've put in. One of the developers like, well, I wrote this code 2 weeks ago, and I noticed that after we did our deployment, it's not in production. What happened to it? It's like, oh my God, we missed it. I'm sorry. You'll have to wait 2 weeks before we can then deploy it. That's another 2 weeks lost to that developer. They'll have to work on something else, by which time they've forgotten about whatever that feature was. They've lost all that context, and the stuff about fast feedback loops and all that is lost. So deployment frequency How about once an hour rather than once a fortnight? That's got to be better, right? It shortens that feedback cycle. It gets the stuff into live quicker. Chances are, if you're doing a smaller deployment, you're only deploying one change at a time rather than a whole batch of changes. And so the deployment frequency really does give you a good indication of how much is being deployed and how often it's being deployed, obviously. And the more regular those deployments happen, let's do 10 deployments in a day rather than one in a fortnight. The higher that number, the better the better everything in the processes are. It proves that your processes are working quick. The feedback cycle is good. The bugs are being deployed effectively and then getting squished quickly. The programmers aren't losing focus and context. And so all of those things can be measured quite easily by deployment frequency. Closely tied to that is lead time for changes. So in my previous example, I mentioned there was a developer who'd missed the window, however that happened, and he had to wait another 2 weeks. A 2-week lead for a change is a very long time and really isn't a fast feedback cycle at all. So the shorter that those lead time changes come down is also another indicator. So in this example, we're looking for a short or a low number. We want a feedback time of, okay, we can deploy that in the next hour. Or if you're not quite ready for that, we can deploy it tomorrow or something like that. But the shorter that change cycle is, again, is another proxy for how good the processes are, how automated they are, how quickly they run, how quickly we can deploy, and all of those things. Closely related to those, mean time to recovery. So this really is the stickers broken, stickers fixed. How long it takes for something to be identified as a bug and for that bug to be resolved in wherever it was spotted. So this is quite a solid indicator that shows that if something breaks in production, how quickly can we code it, test it, deploy it, and get it fixed in production. If you're only deploying to production every 2 weeks and your deployment time is 2 weeks long, then this is going to be really big as a result. So mean time to recovery sometimes takes a different path. I know that some projects, they've got their main features that they build, and that might have a 2-week cadence. Too long, in my opinion. So in order to get around that and to reduce this metric, they have a slightly different release path if you're doing hot fixes or bug fixing, which I think you'll agree with me, if the main path was quick enough and short enough and you're doing a number of deployments every day, you don't need the 2 paths. So the fact that you have to have another process in order to fudge this figure is also showing that some improvement could be made. And the change failure rate. So my first example was, hey, we're doing a change every 2 weeks and we've got, say, 40 odd changes within that one bundle. How likely is that change to result in a failure? Well, 1 in 40, everything being equal. Whereas if you're doing stuff in smaller packages more often, your change failure rate can drop drastically. And so all of these metrics are kind of closely related, but they give you a slightly different angle on what's going on. So the change failure rate of 1 might be every time we do a deployment, it fails. We don't ever want to do a change again. We'll put a change freeze on. That will fix it, won't it? Well, not really. You just get changes backed up even more then. So the only real way around this is to deploy smaller and faster and more often. And that way, your change failure rate might be, instead of every single time we do a change it fails, hey, every 20 deployments we do, one fails. And then because we've got those cycles and those feedback loops all really, really short and quick, we can then fix that really quickly, and our mean time to failure is shorter as well. And I think the best overall key performance indicator for this kind of thing would be customer satisfaction. Who are your end customers? I hope you know who they are. And are they satisfied with the service that they're getting? Now, how much time are they losing in their processes? How quickly are their needs being met? How quickly are the bugs being fixed? And all that can have an effect on the customer satisfaction. So how can you transition to DevOps? Chances are you're using some form of DevOps already, but it just needs to be continuously improved, like I said right at the beginning. But you've got to start somewhere, so I suggest start small. Start with the smallest possible change you can. If there's a deployment that somebody's clicking buttons on, then maybe there's a way of making one less click by changing something in the code. But having one less step and less human interaction. Therefore, it reduces your error rate and all sorts of other benefits. So start small, very incremental. Do one small thing, and then the next small thing, and then the next small thing. It's a bit like going up some stairs. You can't really jump from the bottom to the top of the stairs all at once. You just have to take one step at a time. Another way you can start doing DevOps is to have a cross-functional team. If you're like some of the older organizations I've worked for, then the teams are very siloed. Sure, you might have the same management, but you might have a networking team and a server team and a development team, maybe on different floors of the same building, but they're quite segregated. One way of getting stuff done really quickly is to create maybe a tiger team if we're starting small, and that's to pick one person from each of those teams. So you have a network person, you have a server person, you have a developer person, and you put them in a team and you enable them to work closely together on a daily basis and build a cross-functional team. So that means they can attack all areas. They've all got their different specialities to work on the problem, and that problem can be solved between them, hopefully feeding back to the other teams as well. So rather than having the silos and the teams and they're talking to each other at a very, maybe they're not talking to each other at all. Putting those people in their own team where they can interact directly in order to solve some of the problems might help early on. And as you progress through this, then it might help later on as well. So another approach is what they would call DevOps embedding, where you have a regular team and then you have somebody who has a DevOps skill set and you plop them into that team, and then they can interact with that team and share their knowledge and findings and expertise with that team. Investing in training. So if you've got a great team already and they're enthusiastic, then rather than getting somebody external in, maybe they just need some training. Maybe they just need some pointers. Maybe they just need somebody to mentor them or ask questions to. I know that certainly during my time I've met a number of people that had an interest and wanted to learn more, and their enthusiasm then helped them learn more by asking me lots and lots and lots of questions. You can do that for your team by building their skills. And adopting the right tools. Using appropriate tools can make a world of difference. If your team aren't really au fait with scripting, maybe that there's another tool that could use. I'm trying to think of an example here. So a CI/CD server, many people go with Jenkins because it's free to buy anyway, and it's very popular. There's a lot of skills out there and lots of people understand it, but your team might not. So it might be beneficial for them to pick a different CI/CD server. Maybe something, if you're already running Artifactory, then that's got some CI/CD built into it. If you're running GitLab, that's got some CI/CD into it. It depends on very much on what tools you're missing at the time. So for automation, it might be useful for somebody to have an automation system that they can use, or it might just be as simple as batch programming on PowerShell or even Bash. And then you'll probably need something to monitor. The fast feedback could rely on just the people, the users, the customer telling you stuff, but also the more detailed information like logs and statistics and performance graphs, they're much better suited to using monitoring tools. So there's lots of tools out there. I've got a slide kicking about somewhere where it's like 50, 60 odd tools on there, but you don't need all of them, you just need the right ones. The team you have, if they're enthusiastic and want to learn more, then that's a great culture to have. If they're all siloed and just focus on their own stuff, maybe that's not quite so good. In my experience, I've never met somebody with a bad attitude, because we're all looking to learn things, and in IT, if you don't learn things, you get left behind very quickly. And besides, this stuff's exciting. Who wouldn't want to just constantly learn the next new thing? There's so many shiny things to distract us, which can be a bad thing, by the way. But it's also a good thing, because it means we're also looking and enthusiastic and want to learn more. And so that culture of collaboration, the culture of wanting to learn, the culture of wanting to continuously improve is important to have more than the skills. You can have the support of the skills, but if you haven't got the desire to learn, you don't want to learn new skills. So it's a bit tricky. But certainly the culture and having the good people around is much more important than having somebody that knows absolutely everything but doesn't want to talk to anybody. That's not going to help, because yes, you might have the perfect skills there, but without the collaboration and the desire to learn more, the other kind of things, then you end up with a very strange shaped team. So focusing on culture, particularly if you're interviewing and growing your team, then that will give you more opportunity for that team to grow in a great way. So how does cloud computing figure into all of this? Cloud computing has come quite a long way since Amazon services, or VMware, I don't know if that counts, came along well over 20 odd years ago now. Well, it can help you in a number of ways. Scalability is one of the key ways of it being able to help. You can start really small. That's that thing where I said, if you want to get started in DevOps, where do you start? Well, you start really small. And by using cloud computing, you can purchase units in very small amounts just to get a taster. In fact, Amazon do a free tier, so it doesn't even have to cost you anything when you first get started. But when you want to get started and you've got more demand and you've got more things and you've got a bigger budget because customers are willing to pay for more what you have, then they've got the scalability so that they can help you scale up the technical resources. They can help you scale up the staff that need those technical resources. And so that scale is then there to support you through your journey. I've recently come off of a project where right in the beginning they were hosting 4 services. When I left last week, they were hosting over 1,000. And they have been through a bit of a journey during that scale, but the cloud computing has enabled them to be able to scale that sort of thing without changing lots and lots of stuff under the hood. Cloud computing also offers flexibility. So as well as being able to scale up, which is important if you've got more demand, you can also scale down. This can best be illustrated by having development environments that are only switched on during the week. Heck, even during the day. You switch them on at 8 o'clock in the morning on a Monday, and then switch them off again at 6 o'clock at night. That way, you're only paying for that resource for 10 hours a day rather than 24 hours a day. You've nearly halved your cost of using cloud resources. There's the flexibility of being able to scale up and scale down, and that flexibility enables you to manage your costs effectively, right? Cost efficiency, funnily enough. And so by scaling up and by scaling down, you're only paying for what you're using. You might already have some data center that's hosting your website on production, and that might be in-house. And that's probably quite fair game, because production servers need to be on all the time. You can't really scale those down much overnight, because that might be when your customers are using the service, or perhaps you're international and then they're all over the place. So cloud computing can augment what you already have and give you the flexibility and the scaling on top of what you have right now. The developer machines could be in the cloud because you can switch those off overnight. If they were in your own data center, I guess you could switch them off overnight, but you wouldn't really save much money. Save maybe a couple of electricity bills. But you've still got the hardware that you've paid for or renting for and that kind of thing. So we stick that in the cloud, and we can switch it off entirely and don't pay for it at all when the developers aren't using it. So it can integrate and augment what you already have. And the cloud computing also gives you the global reach. So all of the cloud platforms have data centers worldwide. So if you want to make sure that your application is loading really quickly, you need to have the data close to where the app is. So if you're looking to expand into another country, then you can use one of the cloud providers and use their resources in order to host your stuff in that other country, enabling your reach, moving your data there, keeping it synchronized and stuff, and providing a great service for international customers as well as local ones. So if you want to know more, I've written a book on the subject. How handy. It's called Who Moved My Servers. It's available from Amazon now. Kindle edition, just $2.99. There's a link to it on the screen. I'll also put it in the comments below. And it gives you lots of information about what I've spoken today, those benefits and the where you can start and stuff and things. And did I mention there might be a way of getting it for free? I'm launching a new product called DevOps Answers, available at www.devops-answers.com, where you can ask, or your team can ask questions to me about DevOps on a regular basis. But I'm just gathering and wondering whether I should do this already. So if you're interested in that sort of thing, head on over to devops-answers.com, click through to the wait list, and there'll be a link there where you can enter some information, and in return you can have a free downloadable PDF of Who Moved My Servers to look at. Can't say fairer than that. Okay, so thanks for watching. Blah blah. What do I do now?